bonding in metals, okay? We mentioned this at the beginning of the chapter, the electron C model. So metals have low ionization energies. It's pretty easy to pull electrons off of them. What happens in the metallic solid is that each metal atom donates one or more electrons to this electron C, this big pool of electrons. So we can think of sodium metal as an array of sodium positive ions. And they've each donated an electron, and those electrons are just kind of swimming around. The sodium ions are held together by their attraction for this sea of electrons around them. So they're not going to go flying off in the gas state or anything like that. And overall, the metal has a neutral charge. But these electrons are not localized. They're free to move around, and that is why metals can conduct electricity, because these electrons are free to move. It also explains malleability and ductility. You can pound a metal into a thin sheet. You can draw it into a wire, because the attractions of the sodium ions for this sea of electrons are not directional. And so you put a force here and you smash this. They're just going to kind of bend out of the way. Oh, we'll just squish over here. It's all fine. If you do that with an ionic compound, you get shattering, because when you move those ions away from each other, then the strength of that bond goes down very quickly, and it'll just break. And so ionic compounds tend to just shatter, and they'll form these nice flat surfaces when they break. But a metal will just dent, and you can smash on it. It can accommodate deformation. And then just a little blurb about the Lewis structure of ozone. So oxygen has a double bond, and ozone has this hybrid structure, this resonance hybrid. So I'm just going to draw their structures real quick. I think this is interesting. I'm not going to test you on this, but it's kind of neat. So there's oxygen, and here's ozone. And so we can think of it this way, as being a 1.5 bond. So resonance. So we all know that ozone is important, right? We have an ozone layer that's up in the outer atmosphere, and UV radiation is coming in from the sun. What happens is the UV light is strong enough to break the bonds in ozone, but not strong enough to break the double bond in oxygen. This is like a 1.5 bond. It's weaker than the double bond in oxygen. So what happens is that UV light comes in, the ozone absorbs it, and we get this being broken. So you get an atom of oxygen and an oxygen molecule being formed. Those two then recombine to form ozone again. And so this is how ozone absorbs some of the ultraviolet light that's coming in. So that's a good thing.